so today we're doing section 1-7, which is functions, okay? Today we are going to understand domain and range. We're going to work with domain and range. We're going to work with function notation. We are going to work with relations. We are going to evaluate functions for various inputs, okay? This is our new vocabulary: function, discrete function, continuous function, the vertical line test, function notation, and nonlinear function. Okay? Do any of those words look unfamiliar to you? So a function is a relationship between input and output. In a function, there is exactly one output for each input. You need to make sure that you know that definition. Okay? An equation or a relationship is a function if for every x value there is one and only one y value. Okay? Okay, this one that I even put stars on it to remind me that this is a better definition, okay? So a function is a relation in which each element of the domain is paired with exactly one element of the range. That's a better, this definition is a better definition to write down, okay? So please make sure you write down that one. Now, if we look at these examples, okay, you look at the mapping diagram, you can see that every element in the domain circle maps or points to only one value in the y circle. That is a function, okay? For the vertical line test, what you do is you take a line, and let me see if I can grab a line. You will take a straight line, and then you will move that line from left to right. And you'll notice that as you move from left to right, that line only touches one point on the graph at any given point. All right, so we want to determine whether each relation is a function, and we want to explain. So here, for the mapping diagram, we want to know if that's a function or not. For example A, you can see that every x value points to only one y value. Did you ever see that? Okay, so that is a function. For each member of the domain, there is only one member of the range. So this mapping represents a function. It does not matter if one or more than one element of the domain is paired with one element of the range. So if 3 pointed to 6 and 9, right? Then that would mean that that x value has two y values, then it would not be a function. Do you see the difference? Okay. For the table here, domain and range. 1, the domain is 1 to 4, 3 to 2, 5 to 4, 1 to -4. Is that a function or not a function? What do you think? You see this one? This is not a function because 1 maps to 4 and 1 also is connected to -4. So here, the x value 1 has two y values, 4 and -4. See? in this guided practice, we want to decide whether or not, we want to draw a map and diagram and decide whether or not it is a function. Okay? So I'll give you a minute. So, function or not a function? Not a function. Very good. This is not a function. Okay? And the reason it's not a function is because 2 points to 2 y values. Right? 3 points to 2 y values. Okay? All right. Very good. All right, so here is continuous and discrete functions. All right, discrete function and continuous function. A discrete function is a graph that consists of points that are not connected. Okay, the points are not connected. A function graph with a line or a smooth curve is a continuous function. Okay? For example, before I do this example, I'm going to give you another example. Okay? So let's say you are at the fair, and you go to a stand where the guy at the stand is selling wheels of cheese. Right? Everybody know what a wheel of cheese is? Okay. He only sells them by the wheel. Okay? So, can you ask him if you can purchase just a piece of the cheese? No, you can't. You cannot ask him to cut it, right? Okay. Another example. Say you want to buy a soda. Right? You want to buy soda out of the soda machine. Let's say sodas cost 50 cents. Right? So you put 50 cents in the soda machine and you get out a can of soda. And you drink it. But you're a little thirsty, a little bit more thirsty. You just want a little bit more. Can you put a quarter in there and buy half a soda? No. You cannot buy half a soda. In that situation, that graph or that function is discrete because you cannot get in between each one of those y values. Does that make sense? Okay? All right. In ice sculpting competition, at an ice sculpting competition, each sculptor's height was measured to make sure that it was within the regulated height range of 0 to 6 feet. The measurements were as follows. Team 1, 4 feet. Team 2, 4.5 feet. Team 3, 3.2 feet. Team 4, 5.1. And Team 5, 4.8. So here's the table that shows the relation between the ice sculpting team and the height of their sculpture. Now we want to know what the domain and range of functions are. Well, you can see here are the domain values, right? And here are the range values. And when we write them in set notation. So those are the domains and the ranges. Then we want to write the data as a set of ordered pairs. Okay? We want to write the domain as a set of ordered pairs and then graph them. So here's our ordered pairs. There's the graph. Let me ask you, is that a function or not a function? Is that a discrete function or a continuous function? Why would that be discrete? Can I get in between? Because remember, here, your x values are your team numbers, right? Can you have 1.5 teams? No. So since you cannot get in between here, can I get in between any of these. So that's why it's unconnected. So you do not connect the dots there. That means it is discrete. Clear? All right, very good. Oh, there it is. Okay, the points are not connected, so the function is discrete. All right, so here's the vertical line test. You can use the vertical line test to see if a graph represents a function. If a vertical line intersects the graph more than once, then the graph is not a function. Otherwise, the relation is a function. So let's do the vertical line test. Okay? So for the first graph, grab that. Can you see over there? Can you see over there? So we're going to take that line and we're going to move it. Is that a function or not a function? That is a function. Very good. Next. Is that a function or not a function? Very good, because it crossed the line at the top and the bottom, right? You see that? And then here, one more time. Is that a function or not a function? That is a function. Now let me ask you this. What if that was filled in? Would that be a function or not a function? Not a function. Very good. And the reason being, it would cross, the vertical line would cross the graph at this point and that point. You got it? All right. Very good. Take that off. All right. So recall that an equation is a representation of a relation. Equations can also represent functions. Every solution of the equation is represented by a point on the graph. An equation, when you're looking at an equation, you have an x value going in and you have a y value coming out, right? So that makes it a function, okay? Some equations might give you a graph that's not a function. So, let's see here. The graph of an equation is a set of all of its solutions, which often forms a curve or a line. So here we have the equation negative 3x plus y is equal to 8. And we want to know, is that a function or not a function? Okay? So first we make a table of values. Now, when we make a table of values, you see how my x and my y are both on the same side? It is easier to figure out what your x and your y's are if you just change the equation so that it is a y equals something, okay? So that you can just input the x, evaluate the expression, and then get your y value. So for this, I would suggest adding 3x on both sides. You see that? So plus 3x plus 3x. Does everybody remember that? Solving for y. So then we end up with y is equal to 3x plus 8. So when we put negative 1 into the equation, 3 times negative 1 is negative 3 plus 8 gives me a positive 5. Is everybody clear? So when you are asked to check to see if an equation is a function, if it is not in the form y equals something, You need to put it in y equals something. Got it? All right. So those are the domain and range of the values. We want to connect the points. First, once we get those values, then we're going to plot them on the graph. Okay, so once you get your table of values, then you plot it on a graph, and then you connect the dots. You connect the points with a smooth graph to represent all of the solutions in between. Because could I put 0.5 in there, into that equation, and get an answer? Yeah, I could. I could put 0.5 in there and get an answer. I could put 1/2 in there. Could I put 1/3 in there? Yeah, I could put 1/3. 3 times 1/3, 1, plus 8 is 9. So if we had 1/3 going in, 9 would be coming out. You got that? So, is that a continuous or a discrete function? That is continuous. Because you can get the in-betweens, right? All right, very good. So,
attention force.
all right. So, for the first example, we have 4x is equal to 8. Okay? The first thing we want to do is we want to make a table of values. The question says determine if the relation is a function. So, let's pick some values. Let's pick x is equal to negative 4, x is equal to 0, x is equal to 4. And let's do x is equal to 1/4. Now let's do, 1/4. Now, no matter what I put in there for x, what is my output going to be? No matter what I put in there, what's that going to be? 8. No matter what you put in there, your y value is going to be 8. Is that clear? So when we graph this, we're going to graph negative 4, 8. 0, 8, 4, 8, and 1/4, 8. Okay? And then we draw our line. Is this a function? Yes, it is. Because when you do your vertical line test, it only touches the graph once. Is everybody clear? Got it? All right, so for the second example, I would, before I start anything, I would subtract 8 on both sides so that it would be easier for me to get my table of values. So I'm going to end up with 4x minus 8 is equal to y. So now we can choose our x values and then solve for our y. So let's see, let's pick negative 4, 0. Let's pick 1/4, so we can get rid of that 4. And then let's pick the positive 4. Okay, if that doesn't work, then we'll change the x values again. So now we input the x into the equation and evaluate and evaluate for y. All right, so here are my table of values. Now you can see that these are not the greatest points for me to graph on this line with the -4 and the -24. So I'm going to go ahead and change that. I'm going to go ahead and change that to a -1/4. That might make it easier. Okay, so let's change that -4 into a -1/4. Okay, so when I do that, 4 times -1/4 is -1, and -1 minus 8 is -9. -9. So that is a little bit better. So that means I'm going to count each one of these blocks. I'm going to count by 2's. Okay. So well, I'm going to count. Let's count by 2's on the y-axis. Let's just count by 1's. On the x-axis. Okay? Okay, so now I can graph. So I've got -1/4, comma, -9. Uh-oh. I gotta change my graph again. Hold on. Okay. So I did a pretty drastic change here. So now I can just go ahead and count by 1's and not have to worry about anything. Okay, so this is going to be -2, -4, -6, -8. There, counting by 1's. We've got 1, 2, 3, 4, 5, 6, and so forth. Okay? So now I can put my values on my graph. So I have -1/4, comma, -9. So -1/4, comma, -9 is way down here. Then we've got 0, comma, -8, right there. 1/4, comma, -7. 1/4, comma, -7, about right there. And then 4, comma, 8. That's going to be way up here somewhere, right? So I guess I should have left that in there. So we've got 4, comma, 8 way up here. Okay? Somewhere up here. So now we can draw our line. All right. So when you do the vertical line test for this second example, you can see that that is a function. Okay? Now you'll notice that I erased this part on the first example, and I need to do that one again because I made a little mistake. So let's just go back to that equation, and let's do this again. Now, once again, because it says 4x minus is equal to 8, I want to go ahead and divide by 4. Okay. So we're going to end up with x is equal to 2. And this is how we graph and x is equal to 2. So no matter what value we put in for y, that's where I made my mistake. For no matter what value we put in for y, so if we put a negative, let's say a -3, a -1, a 0, and a 2. Okay? No matter what the y value is, x is always going to be equal to 2. X will always be equal to 2. So, when I graph that, I have -3, x is 2, so x is equal to 2. and y is equal to -3. Okay, one more time. So if x is equal to 2, y is equal to -3. So we've got 2, 1, 2, -3. 1, 2, 3. We also have 2, comma, -1. 2, comma, 0, and 2, comma, 2. So when we draw our line, this is what our graph looks like. And, of course, when you do your vertical line test, you'll see at these points right here, once we get to there, the vertical line will touch every point on that graph. So since it will touch every point on that graph, this is not a function.